The universe is expanding right now, in this exact moment, and you're part of that expansion, whether you realize it or not. Galaxies are racing away from each other at impossible speeds. Whole clusters are vanishing beyond horizons we'll never cross, and yet the strangest part isn't the motion itself. It's that space doesn't expand into anything. It simply creates more of itself. Imagine watching the ground beneath your feet stretch endlessly without an edge, without a direction, without even a destination. That's the reality we live in, and the more we study it, the stranger it becomes. You see, for decades, scientists thought they had expansion figured out. The story went like this. The universe began in an unimaginably hot, dense state. 13.8 billion years ago, it expanded, cooled, and gave rise to stars, galaxies, and eventually us. Expansion should have slowed over time as gravity pulled everything back. Simple, right? But then came the shock. Instead of slowing, the expansion sped up. Something invisible, something we still can't see or touch, began pushing the universe apart with greater and greater force. They called it dark energy, and just giving it a name did nothing to explain what it was. To this day, no one knows. But here's where it gets even more mind-bending. New data from the most advanced telescopes, including the James Webb, suggest the universe isn't just expanding, it's doing so at a rate that defies the very models scientists trusted for decades. Measurements don't agree. One method says the cosmos is stretching at one pace, another insists it's faster. The difference is small on paper, just a few percent, but in cosmic terms, it's a crack in the foundation of physics itself. And when cracks appear at the base of our most trusted theories, it means one of two things. Either we've overlooked something massive, or the universe is playing by rules we haven't discovered yet. Even more unsettling, some researchers now argue that dark energy may not be constant at all. Instead of being this ever-present cosmic fuel, it might be weakening over time. If that's true, everything we've predicted about the far future, from the lonely death of galaxies to the cold emptiness of a big freeze, could be completely wrong. Instead of drifting into eternal darkness, the universe might change course, collapse, or rip itself apart in ways we can barely imagine. Others propose that Earth itself could be sitting inside a gigantic cosmic void, a bubble of space that bends our view of reality and tricks our measurements. If that's the case, the universe might not be accelerating as much as we think. It's our perspective that's warped. And then there's the wildest possibility of all. What if expansion isn't just the growth of our own universe, but a symptom of something bigger? Some physicists believe our reality could be just one bubble in an endless cosmic foam, each bubble a separate universe with its own laws of physics. If true, then what we call expansion might simply be the result of hidden interactions with realities we can't see. Neighbors in a multiverse that stretches beyond all comprehension. So here we are, caught in the middle of a cosmic mystery. The ground beneath our feet stretches silently, invisibly, carrying us into a future no one can predict with certainty. Expansion isn't just about distant galaxies or abstract math. It's about the story of existence itself and why anything exists at all. The universe is rewriting its own rules in real time, and we're just beginning to uncover what those rules might be. And, as you're about to see, the deeper we dig, the stranger the answers become. What if the reason the universe looks so strange isn't because of some hidden force at all, but because of where we're standing inside it? Imagine for a moment that the Milky Way isn't sitting in a typical neighborhood of space, but inside a massive cosmic bubble, a region emptier than average, stretching across billions of light years. To our telescopes, this would create an illusion. Galaxies outside this underdense region would appear to rush away from us faster than they really are, as though expansion itself were accelerating. In other words, Maybe the universe isn't in as much of a hurry as we think. Maybe it's our perspective that's warped by a kind of cosmic mirage. This idea, known as the cosmic void hypothesis, is more than just speculation. Some researchers believe we may live inside a void so vast that it dwarfs anything our imagination can comfortably grasp, billions of light years across, with fewer galaxies, less matter, and a lower density of everything than the regions around it. If true, our instruments wouldn't be lying, but they would be misled. Light traveling through this emptier environment would stretch differently, shifting in ways that trick us into thinking distant galaxies are racing away at impossible speeds. Suddenly, the mystery of dark energy looks less like an invisible hand pushing the universe apart and more like a giant bubble distorting our cosmic vision. Picture yourself standing inside a soap bubble. From within, the curved surface might make the outside world look distorted. Objects would bend, stretch, and shimmer in strange ways. Now imagine the bubble is not made of soap, but of space itself, a vast region where galaxies are sparse, matter is thin, and the very fabric of reality is slightly different from the average. If Earth happens to sit near the center of such a void, then every direction we look would show the same pattern. Galaxies accelerating away from us. It would look like the universe is expanding faster, even if it's not. This possibility challenges one of the most fundamental principles in cosmology, the idea that we do not occupy a special place in the universe. Ever since Copernicus showed that Earth wasn't the center of everything, scientists have worked with the assumption that no spot is privileged. But if the void theory is right, then we do live somewhere unusual after all. Not the center of the cosmos, but the center of a vast, empty patch that shapes everything we observe, the unsettling part. That means our entire understanding of expansion might be built on a misinterpretation. Of course, many cosmologists are skeptical. The size of the void needed to explain the observed acceleration is colossal, far beyond any voids we've mapped so far. And while surveys of galaxy distributions do show enormous empty regions scattered across the universe, none have been confirmed on the ridiculous scale required to account for dark energy. Still, the fact that serious scientists are even considering it shows how desperate we are to solve the puzzle. When every measurement points to contradictions, even the wildest ideas demand attention. But here's where it gets even more intriguing. If we do live in such a bubble, it wouldn't just explain the acceleration, it might also resolve the Hubble tension, that infuriating mismatch between different measurements of expansion. Local measurements taken from stars and galaxies nearby could be skewed by the unusual properties of our void. Meanwhile, observations of the distant cosmos made through the cosmic microwave background would tell a different story, two different perspectives of the same universe, both correct in their own frames, but irreconcilable when compared. It's like trying to measure the speed of a car with a bent ruler. Your answer will depend entirely on where you're standing and how distorted your tool has become. If true, the void hypothesis doesn't just change the way we think about expansion, it changes the way we think about ourselves. It suggests that our position in the cosmos is far stranger and more unique than anyone imagined. We're not in an ordinary suburb of the universe, but in a hollow, empty district where the laws of observation twist in ways we don't yet understand. And if that's the case, then what else might we be missing? Because if a giant bubble can fool us into believing in dark energy, what other illusions might be hiding in the cosmic shadows, waiting to be revealed? If the cosmic void hypothesis challenges the way we measure expansion, then the next mystery goes even deeper. What if the very force driving this acceleration isn't fixed at all? For years, scientists believed dark energy was a constant, a steady background pressure woven into the fabric of space itself. something that, once it appeared, would never change. It was the simplest explanation, and it seemed to fit, but the universe has a way of punishing simple answers, and now cracks are showing in that assumption. New observations suggest that dark energy might not be constant at all. Instead, it could be evolving, shifting in strength over cosmic time, with consequences so dramatic that they could rewrite the universe's future. Imagine for a moment that dark energy is like the fuel of a fire. If that fire burns brighter with time, then acceleration doesn't just continue, it snowballs. Galaxies that already seem to fly apart at impossible speeds would accelerate even faster, tearing the universe apart in an ending so violent it's been named the Big Rip. First, clusters of galaxies would lose their grip and scatter into the void. Then, galaxies themselves would unravel as their stars drift away, unable to hold together. Eventually, solar systems like ours would be ripped apart, planets flung into darkness, and in the final stage, the very atoms making up matter would be shredded, pulled apart by a force stronger than any known bond in nature. The cosmos would end, not in silence and cold, but in chaos and destruction at every scale. On the other hand, if dark energy weakens over time, the story flips completely. Expansion might slow, galaxies could stop drifting apart, and gravity might even claw its way back to dominance. The universe could begin collapsing inward, shrinking until everything is crushed into a singularity again, a big crunch. Out of that collapse, some theorists argue another Big Bang might ignite, starting the cycle all over again. Endless universes, born and reborn in an infinite loop of expansion and collapse. If dark energy truly changes, then the fate of the cosmos is not fixed. It's in motion, unpredictable, like a pendulum swinging between unimaginable futures. But why do scientists even suspect such a thing? The clues come from surveys of galaxies stretching billions of light-years across, measured by instruments so precise they can track the faint tug-of-war between gravity and acceleration over cosmic history. The Dark Energy Spectroscopic Instrument, one of the most ambitious projects of our time, is collecting light from millions of galaxies to see how the expansion rate has changed across epochs. Early hints suggest that dark energy might not be uniform after all. Its grip may have shifted slightly over the last few billion years, and though the changes are subtle, even a small variation could transform the long-term destiny of everything. This idea unsettles cosmologists because it strips away the one comforting piece of the puzzle. A constant dark energy could at least be filed away as part of the cosmic backdrop. Strange but simple. A changing dark energy, though, means we're dealing with something alive in time. A force that evolves and perhaps interacts with other aspects of the universe in ways we don't yet understand. Could it be tied to quantum fluctuations in the vacuum of space? Could it emerge from hidden dimensions that leak into our reality? Or could it be something entirely outside our current physics, a phenomenon we don't even have the words for yet? And if dark energy is changing, what does that mean for us right now? We might be living in a fragile window of cosmic history, one where galaxies still shine, stars still burn, and life is possible. But that window could close. We may be temporary passengers in a universe that is already shifting toward a radically different phase. The night sky we see may be a fleeting illusion, one day erased by acceleration so violent that even light itself can't keep up. Or perhaps we're headed toward a collapse, where the brilliant spread of Galaxies will end not in dispersion, but in crushing return. Every theory, every observation points to one chilling conclusion: the universe's future isn't secure. Dark energy isn't just a mystery, it's a ticking clock, one whose hands we can barely see but whose movement determines everything that will ever exist. And if it truly changes over time, then the most terrifying truth is this: the universe itself is unstable, and what comes next might defy every story we thought we knew. The more we look at the universe, the more one problem refuses to go away. A problem so stubborn that some scientists call it a crisis. It isn't about black holes, or dark matter, or even dark energy itself. It's about a number. One single value that should be the same no matter how you measure it. That number is the expansion rate of the universe, known as the Hubble constant. For years, astronomers expected that as technology improved, their measurements would converge, locking in the true value once and for all. Instead, the opposite happened. The closer we look, the further apart the answers drift, splitting into two camps that simply don't agree. This Hubble tension, as it's come to be called, may be the universe's way of telling us that something is deeply wrong with our understanding of reality. Here's how the paradox unfolds. When scientists measure the expansion of the early universe using the faint afterglow of the Big Bang, the cosmic microwave background, they get a value of about 67 kilometers per second per megaparsec. That's the rate at which galaxies should be receding for every 3.26 million light-years of distance. But when scientists measure the expansion rate today, using nearby galaxies, pulsating stars, and exploding supernovas as cosmic yardsticks, they consistently get a higher number, about 73. Two methods, both precise to within a few percent, both cross-checked countless times, yet separated by a gulf too wide to dismiss as error. At first, many thought it had to be a mistake. Maybe the telescopes were miscalibrated, maybe dust and gas interfered with the light. Maybe hidden biases slipped into the calculations. But as measurements piled up, the problem only grew worse. Different teams, using different instruments, different techniques, all landed on the same divide. The early universe and the modern universe tell two different stories about how fast space is growing, and since both can't be right, the tension cuts into the very foundation of cosmology. Some scientists argue that the solution might be simple, that we've overlooked a detail, some hidden systematic error buried in the data. But others see something far more profound, evidence of new physics. Perhaps dark energy behaves differently across time than we've assumed, subtly altering expansion rates at different epochs. Or maybe unknown particles, invisible relics of the early universe, warped the physics of the first few billion years. Some even suggest that gravity itself might change on cosmic scales, breaking Einstein's equations in ways we've never seen before. The James Webb Space Telescope was supposed to help settle the debate, cutting through the fog with sharper vision than ever before. Instead, it deepened the mystery. Webb's precision confirmed the higher local value, supporting the side that suggests the universe is expanding faster than the early data predicts. This wasn't the resolution scientists were hoping for. It was a confirmation that the tension is real, not a mistake, not a statistical fluke, but a genuine crack in our model of the cosmos. And if the model breaks here, who's to say where else it might fail? Think of it this way. The Hubble constant is like the universe's heartbeat. If you can't measure a heartbeat consistently, then you don't really understand the body you're studying. That's what makes this tension so disturbing. It isn't just about one number. It's about the possibility that our entire framework for how the universe works is incomplete. Something hidden, something unaccounted for, may be shaping the cosmos in ways that make our neat equations fall apart. And the most unnerving part, whatever the answer is, it's not going to be small. A tiny error wouldn't survive this much scrutiny. The Hubble tension has been tested, challenged, and checked to exhaustion. What remains is the growing sense that the universe is sending us a message, that the story we've written for it is missing entire chapters, and those chapters might rewrite everything we think we know. One of the strangest illusions the universe plays on us is the idea of being at the center of everything. When Edwin Hubble first revealed that galaxies were fleeing in all directions, it was tempting to assume that Earth, or at least the Milky Way, occupied some privileged position in the cosmos. After all, when you stand still and watch everything else move away, what else could you conclude? But this apparent centrality is just that, an illusion. The truth is far stranger, and it cuts against every instinct we have about space. In reality, the universe has no center, and every single point in space experiences expansion as though it were the center of the show. Imagine dots on the surface of a balloon. As the balloon inflates, every dot sees all the others moving away. If you were standing on one of those dots, you'd swear you were at the center of expansion. Move to another dot, and the exact same illusion plays out. No matter where you stand, the story looks identical. That's the trick of metric expansion. It scales distances everywhere equally. There's no preferred location, no true center where it all began. The Big Bang wasn't an explosion in space. It was an expansion of space itself, happening everywhere at once. This is why, when you look into the night sky, you see galaxies rushing away from you in every direction. But if you were standing in some distant galaxy, you'd see the exact same thing. Every observer, no matter where they are, sees themselves as the middle of expansion. It's like an infinite hall of mirrors, each reflection showing you as the focal point, even though none of them actually are. The cosmos plays this illusion perfectly because expansion itself doesn't need an origin point. It's built into the geometry of space-time. The idea is hard to grasp because our everyday experience doesn't prepare us for it. Explosions have centers. Ripples on a pond have sources. But the universe doesn't follow that script. When cosmologists trace expansion backward, they don't find a spot in space where it all began. They find a moment in time. A moment when space itself had no size at all. Every particle, every atom, every galaxy that would ever exist was compressed into that singular beginning. When expansion started, it wasn't confined to a place. It was everywhere. The universe didn't grow into something, it created its own arena as it expanded. This centerless nature has profound consequences. For one, it means that the edge of the universe doesn't exist in any way we can point to. Just as the surface of Earth is finite but without edges, the universe might be finite yet unbounded, or it might be infinite outright. Either way, there's no boundary you could ever reach. No wall where space suddenly ends. The observable horizon is not a true edge, but a limit of what light has had time to reach us since the Big Bang. Beyond it, expansion has carried regions of space so far away that their signals can never catch up. They exist, but they're forever cut off from us, sealed behind a cosmic curtain. If that weren't strange enough, the illusion of centrality also hints at something deeply unsettling. No matter how advanced our science becomes, we will always be prisoners of perspective. From our vantage point, we see a universe with us at the center, and from every other vantage point, the same truth holds. There is no ultimate viewpoint, no cosmic throne from which the real picture can be seen. The universe is democratic in the purest sense. Every point is as important and as unimportant as every other. But this revelation only raises the stakes. If there is no center and no edge, then what exactly are we expanding into? The balloon has air around it. The pond has a surface it ripples across, but the universe expands into nothing. Nothing not as empty space, but nothing as in no outside at all. It's a concept so foreign to human thought that even the word nothing fails to capture it. And yet it's this paradox, centerless, edgeless, boundless, that defines the very fabric of reality we live in. If the fate of the universe hinges on dark energy, then understanding it becomes the most important mystery in all of science. Yet here's the shocking truth. Nearly everything you've ever known, touched, or seen makes up less than 5% of reality. The stars in the sky, the planets beneath your feet, your body, your memories, every atom in existence, all of it is ordinary matter. And the rest? The overwhelming 95% of the universe is invisible, untouchable, and for the most part completely unexplained. About 27% is dark matter, a strange ghostly substance that exerts gravity but emits no light, and a staggering 68% is dark energy, the force that stretches space itself apart. These two unseen players control the evolution of the cosmos, yet we know almost nothing about what they actually are. Dark matter is at least a little cooperative. It leaves fingerprints. Its gravity sculpts the cosmic web, bends light from distant galaxies, and creates patterns in the cosmic microwave background. Without it, galaxies wouldn't hold together and large-scale structure couldn't exist. But dark energy is far more elusive. It doesn't clump or gather. It doesn't bend light. It doesn't reveal itself in any way except by its effect on the expansion of the universe. It fills every cubic inch of space equally, unchanging no matter where you look. Even more bizarre, as the universe grows, dark energy grows with it. The more space there is, the more dark energy exists. It's as though the cosmos is creating energy out of nowhere, violating the most basic rules of conservation we take for granted. The leading theory suggests that dark energy is simply the energy of empty space itself, the vacuum energy predicted by quantum mechanics. Quantum theory says that even a perfect vacuum isn't truly empty. It seethes with virtual particles constantly flickering in and out of existence. That jittering background field should contribute energy to space. The problem is, when physicists calculate how much energy this vacuum should contain, the result is wrong by an unimaginable factor. The predicted value is larger than observations by a number so absurd, it's been called the worst prediction in the history of physics, off by a factor of 1, followed by 120 zeros. That's not a small mistake. It's a cosmic scale disaster for our theories. Because of that, some scientists believe dark energy isn't vacuum energy at all, but something new entirely. Perhaps it's a field that evolves over time, waxing and waning in strength as the universe ages. Others suggest it could emerge from hidden dimensions, a leakage of gravity from realms we can't perceive. Some even argue that our understanding of gravity itself is incomplete, and what we call dark energy might simply be a sign that Einstein's theory doesn't fully describe the universe at the largest scales. Each possibility points to physics beyond what we currently understand. Each could reshape not just cosmology, but our entire view of reality. What makes this even more unsettling is the dominance of dark energy. It's not a minor background force. It rules the universe. It already dictates the rate of expansion. It already shapes the future. And it already outweighs every star, planet, and galaxy combined. Ordinary matter, the stuff of life, is little more than cosmic decoration in a reality commanded by forces we cannot see or measure directly. And the irony is brutal. All of science, all of history, all of human experience is built on studying the tiny fraction we can actually detect. We are the minority in a universe dominated by mysteries. This realization changes everything about how we see ourselves. We're not just small compared to the size of the universe, we're relevant compared to its true content. Our galaxies shine, but they're only the flickering sparks on the surface of a vast, invisible ocean. And unless we figure out what dark energy really is, we'll never know whether the universe will drift into cold emptiness, rip itself apart, or collapse in on itself in fiery rebirth. The most important force in the cosmos is the one we understand the least. That truth alone should terrify us and inspire us, because solving the mystery of dark energy might be the closest humanity ever comes to unlocking the ultimate secret of existence. The story of cosmic expansion is more than a tale of galaxies drifting apart. It's a mirror held up to reality itself, showing us that the universe is stranger, larger, and more mysterious than we could have ever imagined. From Hubble's first shocking discovery that galaxies flee from us in every direction, to the James Webb Space Telescope confirming that expansion accelerates in ways we can't explain, every step forward has revealed deeper puzzles. We began thinking space was an empty stage where matter acted out the laws of physics. Now we see that space itself is alive with growth, stretching faster than light, carrying galaxies away on a ride with no brakes and no clear destination. What makes this journey even more astonishing is that expansion touches every scale of reality. Atoms remain intact, stars keep burning, and galaxies hold together only because local forces overpower the stretching of space. Yet on the grandest scales, where nothing can resist, expansion rules absolutely. It creates the illusion that every point is the center. It hides unreachable regions beyond a cosmic horizon, and it guarantees that most of the universe will forever remain invisible. What we see is not all there is. The observable universe, vast as it seems, may be nothing more than a small bubble in a reality that stretches without end. And in that endlessness lurks the greatest mystery of all: dark energy, the silent tyrant of the cosmos. It makes up nearly 70% of everything, yet it remains nameless, shapeless, and unexplained. It's the reason expansion accelerates. It's the reason galaxies will slip away from sight. And it's the reason we don't know how the universe will end. Maybe in eternal cold, maybe in catastrophic rip, maybe in fiery collapse. All of it depends on something we can't touch, can't see, and can't even describe with certainty. For all our equations and telescopes, the universe is still keeping its deepest secret locked away. But perhaps the most mind-bending realization is that this isn't just about the far future. Expansion is happening right now. The space between galaxies grows as you read this. The light reaching your eyes tonight has been stretched across billions of years of expansion. Even the atoms in your body, though tightly bound, ride the tide of cosmic growth on scales too small for you to feel. You are part of the expansion, inseparable from it. Every thought, every dream, every heartbeat unfolds on a stage that is itself stretching beneath you. And that raises the ultimate question: not just what the universe is doing, but what it means. If space expands into nothing while creating everything, if the majority of reality is made of invisible forces we can't explain, if our lives take place in a cosmos whose destiny hangs on mysteries beyond human reach, then what does it mean to exist at all? Some might find despair in the idea that we are temporary, fragile patterns of matter in a universe destined for emptiness. But there is another way to see it. Against impossible odds, in a cosmos where 95% of reality is unknowable, consciousness emerged. You exist during the one fleeting chapter when stars shine, when galaxies blaze, when the night sky tells a story. You are alive in the universe's most vibrant moment, a brief spark of awareness in an expanding ocean of darkness. Perhaps the true meaning of cosmic expansion isn't about where the universe is going, but about what it allows here and now. It allowed stars to form, planets to take shape, and life to arise. It allowed atoms forged in ancient supernovas to become your body. It allowed you to look up, to question, to wonder, and to know that space itself is growing beneath your feet. The expansion is terrifying, but it is also the reason you exist. In the end, that realization is both humbling and exhilarating. The universe is vast, mysterious, and unstoppable, but for this fleeting moment, you are here to witness it, and that alone is extraordinary.